in the lectures, we have introduced the simulation data, right? So the grid.nc, we have some lat cell and then long cell. You can find the gridded the locations of different cells in the grid.nc. And after you have generated the simulation data, you will have something called a diet.nc, diagnostic.nc. And basically these data are unstructured. So in the previous tutorials, we only deal with ERA5 data, which are the structured data. They have separated latitude and longitude, and so they have as XY dimension. But these unstructured, so in our simulation data, the coordinates are unstructured, and you can see from the examples below. And here we have a new function called the matplotlib.try here. And this is the function that used to plot the tri-mesh data. Basically, it supports unstructured data as well. So we use this function in this session. This is the main function in here. Run it. And in this session, we use the data from the demo CPAS. Yeah, CPAS. And first of all, grid.nc, we have studied before. It has some variables like the neighboring cell. I think it has neighboring cell, right? Oh, I forgot it actually. So it is the grid information of this example provided. And then for diet.nc, so if you first go to the Jupyter server here and you browse the data, for example, I go to here and I go to RSIM, and then this is the initial condition, and then I go to ATM. So you can see these are the simulation outputs, and it contains like hourly simulation outputs up to this date. So the share screen button is a bit annoying. Okay, so here if you want to combine all the diet.nc from different time steps together, this is a wildcard. I think some of you may know wildcard is. It represents any characters between these two things. So basically, I specify the directory of the diet.nc first, and then I use this function, openmf dataset. Openmf dataset is a function in Xarray used to open multiple .nc file. And first of all, I need to specify all of the diet.nc in the first argument of this function here. And so some of the other variables are pretty tricky. For example, when you have multiple data set, you need to have a coordinate. You need to have a dimension that combines all of these data sets. So these are the time dimension. But in this function, if you don't specify the time dimension that you want it to combine the data, it will not know. And so you need to specify here concat dimension, which is time. So it will help you to combine the data with respect to the time dimension. And this is the method of combination. We use nested here. So if we check the APM and API here, you can see combine. The default is by coordinates. So by coordinates means that if you have some, for example, if you have two data sets here, and then it contains time lat long, and then here is also time lat long, and then you specify the concat dimension as time, you will use this argument because it knows the time dimension here. It already knows the time dimension here. But in nested method, Actually, we don't have this time dimension. In each of the data set, we only have lat long. So you need to ask the function to generate a new dimension for you. So this is the method to help you to generate a new dimension, which is specified here as a time dimension. So I just run this cell here, and then you can see it is a time dimension that I ask the function to generate. And the time, it has a 37 data set. So in total, it has a 37 time steps here. And the n cells is basically the dimension of the grid. So it basically means, so for example, the first cell, I have a value like something, it contains data values of these here. And in the second cell, it contains variables of these here. So n cell is basically the dimension of the cell. So it specifies the position and the index of different cells in the mesh here. So let's move on to the main part. So if we want to draw these unstructured data, we cannot use the function that we introduced before, the ax.contour, ax.contourf. Well, we cannot do this here because those functions are for structured data only. So in the unstructured data, we will use the try contour function instead. So how do we do this? Now let's move. Okay, so let's move on to here first. So in this try contour function, you need to specify the longitude and latitude of each of the cell, and then the MSLP. So this is the value that we want to plot. So basically, long cell and lat cell here are from these here. So the origin is from this one, the grid.nc, the lat cell argument, the lat cell variable from the grid demo grid. So the grid.nc is basically, and then the MSLP is just the output variable MSLP here. And I plot the last time step of the data. So I specify from using the ISCL function. And if you plot this here, if you run this cell here, you can see, let's ignore this one first because it's basically the output that mean sea level pressure. And for the lat cell and long cell, it contains the latitude information of each of the cell, and then the longitude information of each of the cell. So, and you can see they all have the dimension of n cells here. The dimensions are the same. So it basically means that in each of the cell, it has latitude of this one and longitude of this one, and then it has a mean sea level pressure value of this one. And this is the meaning of the data set and the data structure of unstructured data. And here I do some processing here because I want to convert the unit of mean sea level pressure from Pascal to hectopascal. And in these arrays, it's actually in the unit of radian. So when you maybe, you can see those are, I don't know what these are. Actually, we have introduced it in the lectures. These are all radians, right? So you need to convert it to degree in order for the plot to know what these coordinates are. So yeah, convert to degrees, and you can see the first cell is at 90, is at the North Pole, and yeah, these are degrees of the cells. And here I generate the contour plot. So these are the basics functions. I don't have to go through them again. And here I apply the try contour function in this AX object. So you need to specify the longitude, latitude, and mean sea level pressure, and then these are some of the attributes, and you just plot it here. And you can see the output is something like this. So this is the same for contour F function. So I just demo it here. You can see it here. So this is the, using the try contour F function, you can generate a fielded contour for the unstructured data, which is real simulation data. And then you can see the color bar here is very big because of the, maybe because it's related to this function, try contour F function, and the figure size as well. So you can shrink it, apply the shrink parameter, and then try to make it smaller. But sometimes it's annoying if you need to apply this parameter every time you generate a plot. So it has, like, I have another method for you to make it a little bit easier is to add another access for this color bar. So these are the same codes that we use in the last cell. And then here, this is where the difference comes from. So first of all, I applied this add access function so that I add a new access to these figures, and I define the position. So these are the position of, so x1 is basically the right-hand side of this axis. And I want it to be a little bit more right of this axis. And here I want the bottom of the new axis to be the bottom of the original axis here. So I type y0. So y0 is basically the bottom of this axis, the position. And these are the width and height. So, and then you can see the output here. And then I assign this axis to a variable called CAX. And then I ask the color bar function to draw the color bar in this axis. So this is the idea of the whole code.